Logarithmic, nobody spells out logarithmic. Nobody calls them logarithms. Everyone calls them logs because we're lazy. Okay? And I remember when I was in Algebra 2, my Algebra 2 teacher handed us this worksheet, you know, on this first day of talking about logs, and the title of the worksheet was The Whole Forest. And on this paper was like 150 like log problems that were literally cut and paste onto this paper. Like, so like you'd have like 21 through 32 like right here, and then like sideways you'd have like 45 through 50, and then long ways here like just all discombobulated everywhere. And it took me a couple days. I was like, the whole forest, because it was logs and logs and logs and logs and 150 log problems, and it's a pun, right? Logs, trees, forest. Yeah. Okay? And if we had the time, you'd get the whole forest too, because it's the only way to learn logs. Just repetition over and over and over again. You know, this kind of problem 6, 7, 8 times, that kind of problem 6, 7, 8 times, and so on. Okay? Now, here's the idea behind the log function. The first section that we did in this chapter was inverses, right? Then the next section was exponential functions. So the question that's going to be coming up is, what is the inverse of the exponential function? All right, if I have y equals, let's say a to the x, what's the inverse of that function? If I give you an equation and I ask you to find its inverse, do you remember what you're supposed to do? Switch x and y. So x equals a to the y, but then you're supposed to solve for y, right? Okay? So how do I get this y by itself?
Do that switch thing?
Switch it back? No, I'm not doing the inverse. Terrific. There's no way. There's no way to get my y out of this exponent. It's stuck there. So you know what we do? We make up a function. We say this isn't going to work. We say the inverse is going to be y equals the log base a of x. That's going to be its inverse. We just make up a function called the logarithm. Okay? Because otherwise it's impossible to solve for y. Alright, so that's the first thing that I wanted to accomplish. The next thing I want to do is I want to talk about the relationship between the exponential function and the logarithmic function. Okay? They're inverses, but you can also think of them as two sides of the same coin. Okay? Just like you can think of subtraction as the opposite of addition, but you can also think of subtracting as adding negative numbers, right? You usually don't, but you could. Agreed? Ditto for multiplying and dividing. They're opposites, but you could also think of dividing as multiplying by fractions. Dividing by 2 is like multiplying by a half and so on, right? Okay, same sort of thing. We're going to take equations that are written in exponential form, and we're going to rewrite them in log form. Okay? And in this case, we're not really doing inverses. We're going to be writing equivalent equations. Okay? But we're just switching some stuff around. So in exponential form, you know what? I might change my notation. I'm going to call it y equals b to the x. And I'm changing it from a to b because I want to use b for base. Okay? So I've got b to the x power. That's my base. That's my exponent. Does anyone have a good name for this number here? In all my years, I've never come up with a good name for it. So, Richard? Does that work? Okay. Unless you got a better name, we're going to call him Richard. Okay? So we've got the base, we've got the exponent, we've got the third number, Richard. Okay? So in logarithmic form, the equivalent equation, not the inverse, but the equivalent equation is x equals the log base b of y. Okay? And when we read these guys, I want you to say that exactly like I said it. I don't want you to call it log b. I want you to call it log base b. There's a really strong reason, there's a really important reason why I want to reaffirm that that's called the base.